Morning, everybody. Then today we are going to take the one demonstration of practical, and name of that practical is estimation of serum alkaline phosphatase. All of you know how serum is separated. You know what is the difference between serum and plasma? Because after collection of venous blood, take this blood in the plain container. Then after some time clot will be formed, and then serum is released from that clot. It is called as serum, and we are measuring the activity of enzymes in serum. Okay, so that's why this is the name of this practical, estimation of serum alkaline phosphatase. All of you know this is the diagnostic estimation. This is used for the diagnosis of various disorders, and this enzyme activity is mostly highly increased in obstructive jaundice. You know what is meant by obstructive jaundice? There is obstruction of bile duct. What is hemolytic jaundice? Increased hemolysis is there. Hepatic means there is impairment of liver function. It is called as hepatic. And obstructive means there is obstruction of bile duct. Okay? Because enzymes. Why enzymes are released and increase their activities in serum? Because specific enzymes are present in specific tissues. And if there is any destruction of that tissue, and the release of this enzyme from that tissue and enter into the circulation, that's why this enzyme activity is increased. For example, this alkaline phosphatase activity is increased in obstructive jaundice because this enzyme is present in bile duct. Also, another example, if there is destruction of pancreatic gland, leads to increase the activity of serum amylase as well as serum lipase. You know myocardial infarction? In that infection, some enzyme activities are increased. All of you know some examples. SGOT, serum glutamate oxygenate transferase or aspartate transaminase. Second is creatine phosphokinase, muscle brain. It is the isoenzyme. And third one is lactate dehydrogenase. What is the role of lactate dehydrogenase? This part is completed in your 12th standard, 11th and 12th standard. Pyruvate to lactate in anaerobic condition. Okay, these three enzymes are increased in cardiac arrest or heart attack. Also, the alkaline phosphatase activity is increased in obstructive jaundice, some during the formation of some bones. And this enzyme activity is also used for the diagnosis or to check the severity of the disease. Okay. Why it is called as phosphatase? You know what is enzyme commission number? You know IUC classification of enzyme? There are 6 classes are there. 6 types are there. This enzyme belongs to which class? You know? Hydrolase. Correct? Hydrolase enzyme. Okay? That's why first number is 3. Then sub number, enzyme commission number, etc. etc. That's why its enzyme commission number is 3131. And this enzyme is mostly belong to hydrolase category. Then this method is used for the estimation of this enzyme activity. Also some other methods are there, enzymatic method, but these methods are routinely used in clinical laboratory. Okay, but for calorimetry purpose, we are using this method, King-Armstrong method. Why this name is King-Armstrong? Because This method is applied by this scientist, Kim Armstrong. That's why name of this method is Kim Armstrong method. Let's see the principle of this method. All of you know principle. In the calorimetry, this part is completed. Biochemical substance or enzymes reacts with some chemicals to form color product, and concentration of that color products depends on substance present in the biological fluid. Same method is for the estimation of serum enzymes. Okay, these are the enzymes phosphatase, which hydrolyze monophosphoric esters. You know ester groups. Monophosphoric means it contains single phosphate maltase. Give an example: monophosphate. AMP, adenosine monophosphate. ADP is triphosphate. They contain 3 phosphate. It is the one example. Which hydrolyze monophosphoric esters to liberate phosphoric acid. This alkaline phosphatase enzyme. Why this name is alkaline phosphatase? It's because this enzyme is active in alkaline medium. That's why name of this enzyme is alkaline phosphatase. Also, so another enzyme is there, acid phosphatase. That this enzyme is active in acidic medium. That's why its name is acid phosphatase. And this is alkaline. And you know blood pH is slightly alkaline, 7.4. Okay. This enzyme hydrolyzes monophosphoric esters to liberate phosphoric acids or phosphates. Enzyme alkaline phosphatase hydrolyzes organic phosphorus like disodium phenyl phosphate. You know one example in glycolysis, phosphorenol pyruvate. Okay, like that. This hydrolyzed organic phosphorus. It hydrolyzed organic phosphorus, for example, disodium phenyl phosphate under defined or specific conditions of time, temperature, and pH. Why these 3 points are considered? Time, temperature, and pH. Because here this enzyme is active in specific pH, alkaline pH. That's why pH is important. Okay. Temperature. Because our body temperature is 37 degrees centigrade, and there is need to measure this enzyme activity at 37 degrees centigrade. That's why temperature is also very important. And what is the use of time? Mostly time is used for the calculation purpose, because at specific time activity of enzyme is how many units. For example, at fixed time this enzyme hydrolyzes how much amount of diammonium phosphate? 2 for phosphoric acid. How much amount of phosphoric acid liberated within a specific time? That time is very important. You will use more time, large number of phosphoric acids are synthesized. And it is very difficult because after some time activity will be reduced. That's why specific time is very important for the calculation purpose. Understood? That's why these 3 points are very important. We are measuring any enzyme activity at specific time, specific pH, and fixed temperature. These 3 points are very important while considering the estimation of any enzymes. Understood this? First reaction, disodium phenyl phosphate is converted to phenol and phosphoric acid. And here we are measuring this enzyme activity as pH 10. It is alkaline. Temperature 37 degrees centigrade. And time is 15 minutes. At the end of this session, you will know why these 15 minutes are used. In 15 minutes, how much amount of phosphoric acid is liberated depends on the concentration of that phosphoric acid. We are measuring the activity of alkaline phosphatase activity. Understood? The phenol liberated then react with these 2 chemicals, 4-amino antipyrine and potassium peroxide. Even in presence of proteins due to high pH to give reddish brown color. You know this reaction, similar as glucose. Phenol reacts with 4 amino antipyrine and phenolic glucose. But here, phenol reacts with 4 amino antipyrine and potassium ferricyanide to form reddish brown color. And the intensity, color intensity is read colorimetrically at 530 nanometer and compared with that of standard phenol solution treated similarly. Understood this? Why this 530 nanometer wavelength is selected for this estimation? Huh? This is visible reason is correct because at specific color, specific wavelength is selected because at that color, that fixed wavelength is selected because at that wavelength you will get maximum optical density or absorbance. If wavelength is increased or reduced, you will get less number of the absorbance of optical density, and this will not proportional. These readings are not proper for the calculation purpose. That's why specific wavelength is selected for the specific colored solution. And for this color, this 530 nanometer wavelength is selected because at that wavelength we will get maximum optical density or absorbance of that color. Understood? This part is completed in colorimetry. Understood this principle? Alkaline phosphatase hydrolyze monophosphoric esters to liberate phosphoric acid. Here, this enzyme hydrolyze organic phosphorus, for example, disodium vinyl phosphate, under defined conditions to form phenol and phosphoric acid. This phenol liberated. How much amount of phenol liberated reacts with 4 amino antipyrine and potassium ferricyanide to form reddish brown colored complex. And intensity is measured at colorimetrically at 530 nanometer. Also, standard phenol solution is treated similarly and color intensities are compared. This is the principle of this method. Then this slide shows the reagents used for this estimation. These are the reagents or chemicals used for this estimation. First is substrate is used for the hydrolysis purpose. Disodium vinyl phosphate. Second, alkaline buffer is used. You know what is the definition of buffer? Okay. It is the solution which resists the pH either addition of alkali or acids. It is the buffer. Buffer is in that buffer. These two chemicals are used: sodium carbonate and sodium bicarbonate. And pH of that buffer is 10. Then sodium hydroxide is used, 0.5 normal. Then sodium hydrogen carbonate is used, 5%. Then 4 amino antipyrine and potassium ferricyanide here. This is for the formation of color product or indicators. 4 amino antipyrine and potassium ferricyanide. Next is standard phenol solution. What is this of standard? Its concentration is known. That's what is called as standard. And the standard is reacts with same chemicals to form color products. And at standard, we will get two readings: concentration as well as optical densities. Okay? And concentration is 0.01 milligram per ml. How to prepare this 0.01 milligram per ml? Suppose example, you will prepare the 100 ml, 0.01 milligram per solution. Take 1 milligram phenol and add 99% water to form 0.01 milligram per ml standard phenol solution. Understood? What is the calculation of this? Add ml, 1 ml into 100. That's why 0.01 into 100 means 1. It is equal to 10 divided by 94 micromoles per ml or 0.106 micromoles per ml. This slide represents the procedure of the estimation of serum alkaline phosphatase. Label 4 test tubes as blank standard, control, and unknown, and make following additions. Huh? First is the substrate. Substrate means disodium phenol phosphate. Add 1.1 ml in all tubes. Then add buffer. Buffer means 10 pH solution. Sodium carbonate or bicarbonate is used. Add 1 ml in only control and unknown. Okay. Then add distilled water in black. Then add phenol standard in only standard. Then incubate 37 degrees centigrade for 5 minutes. And then add 0.1 ml serum solution in only unknown tube. Because this enzyme is active in that only unknown tube. And this enzyme will convert disodium phenol phosphate to phosphoric acid and phenol. In this tube, only phenol is liberated. And in standard, directly phenol is provided. Okay? Standard means standard phenol solution. Okay? But reaction occur in only unknown tubes. And then here, incubate at 37 degree for 15 minutes. This factor is used for the calculation purpose. In 15 minutes, how much amount of phenol is liberated by enzyme activity? Here, we are providing sufficient amount of substrate, disodium phenol phosphate. And production of this phenol and phosphoric acid depends on how much amount of enzyme present in serum. Understood this statement? Here we are providing sufficient amount of disodium phenol phosphate as a substrate. If enzyme activity is low concentration of phenol is liberated. If enzyme activity is high amount of phenol is liberated. Phenol liberation is depends on the alkaline phosphatase enzyme present in serum. Understood? Then add some other chemicals, alkalis, 0.5 normal sodium hydroxide. Add 0.8 ml in all tubes. Next is 5% sodium hydrogen carbonate, 1.2 ml in all tubes. Then add serum in only control tubes, 0.1 ml. Here, reaction will not occur because we will not provide the sufficient dose for the reaction purpose. Okay? But this serum is added. Then add 2 indicators, 4-amino antivirin and potassium hexacyanide, 1 ml each in all tubes. This is the procedure. This procedure is given in your journal. All of you have purchased new journal. Take, mix well and read immediately at 530 nanometer or green filter. Understood this procedure? Reaction occur in only unknown tube. In control, there is serum is not there. In standard, serum is there. In control, serum is there. But we will not provide the sufficient time for the reaction purpose. In standard, directly non-standard phenol standard is used. Non concentration phenol standard is used. And in black, only reagents are there. Because some reagents have their own color. To remove that error, this black is used. You know there are 2 types of blacks. Water black used to set the zero reading of the colorimeter, and reagent blacks. Due to the own color of reagent, to remove that error, reagent black is used. Understood? What is the procedure of this estimation? You know this table? Observation. What are the readings of? Blank, standard, unknown, and control. Then see the calculation. This formula is used for the calculation of the serum alkaline phosphorus activity in Kim and Armstrong unit is equal to optical density of unknown minus optical density of control divided by optical density of standard minus optical density of blank into concentration of standard in ml or milligram per ml into volume of standard used. This is given in our procedure. Into 100 divided by volume of serum. Okay? Then, in this words, concentration of sand is 0.01. Volume of standard 1 into 100 divided by volume of serum 0.1. That's why multiplication factor is 10. Okay? This formula is used for the calculation of serum alkaline phosphatase enzyme activity in King Armstrong unit. I will give some readings to you. Okay? For the calculation purpose. Read this slide. What is the definition of King Armstrong unit? Milligram of phenol liberated by enzyme present in 100 ml of serum at 37 degrees centigrade in 15 minutes. Understood what is the definition of King Armstrong unit? How much amount of milligram phenol is liberated by enzyme present in 100 ml of serum? Understood why this 100 factor is used in calculation purpose? Why this 100 is used? Because it is related to what is the definition of King Armstrong units. Because we are measuring the activity in 100 ml of serum. That's why this 100 factor is used here. Understood definition and why this 37 under specific condition, specific time, specific pH and specific temperature is used for the estimation of enzyme activity. Understood? Why 37 is used? Here. Understood definition? Any doubt? This is normal range. Normal range of the serum alkaline phosphatase activity is 3 to 13 King Armstrong unit or 23 to 92 international unit per liter. This part is completed in the enzyme topic. IU per liter. Okay. This is the normal range of the serum alkaline phosphatase activity. Then let's move to clinical conditions. Interpretation. Alkaline phosphatase exists as several isoenzymes which are found in the following tissues. You know what is meant by isoenzyme? This part is not completed, I think. Different forms of enzymes catalyze same reaction. This is the definition of isoenzymes. And these different forms are present in different tissues. But these enzymes catalyze same reaction. That's why specific isoenzyme activity is increased in the specific organ destruction. Understood? What is meant by isoenzyme? And there are different isoenzymes are present. Alkaline phosphatase alpha, beta, alkaline phosphatase heat stable, heat labial. These are the some examples of the isoenzymes of the serum alkaline phosphatase. Understood? Isoenzyme different forms. For example, CKMB, there are two types are there. One is muscle and one is brain. Therefore, three isoenzymes are there. CKMM, muscle, CKBB, muscle brain, and CKMB. Both heterozygous subunits are there. That's why CKBB. Like that, different isoenzymes are of alkaline phosphatase are there, and specific isoenzymes is present in specific tissues. And if the any destruction of that tissue, that specific isoenzyme activity is increased. Understood isoenzyme? And these isoenzymes are present in these tissues. For example, liver, bone, placenta, intestinal epithelial cells, and kidney. You know in liver function, bilirubin, protein, HEOD, HEPT, as well as alkaline phosphatase activity is measured. Okay? And in the specific tissues, specific isoenzyme activity is measured. And increase the serum alkaline phosphatase activity is seen in various physiological and pathological conditions. First, see the physiological conditions. First is slightly higher levels are found in the late pregnancy after parturition. Because in pregnancy, bone formation process is going on. And in any bone formation processes, this enzyme activity is increased. And after the increased activity, phosphorus level is increased in serum. And that phosphorus is used for the formation of bone. That's why in pregnancy or in sometimes growing children, slightly higher alkaline phosphatase activity is observed. Understood? What is the reason why the pregnancy alkaline phosphatase activity is slightly higher? Understood? Next, high levels are found in children, particularly during the growth. See the some pathological conditions, and these conditions are divided into two categories. First is hyperactivity is observed in bone-related disorders, and second is hyperactivity is observed in hepatocellular injuries, liver-related hyperactivity. First is it increases the activity of the alkaline phosphatase in the bone disease with high osteoblastic activity. Here bone formation is there. First is Paget disease. Also there is bone formation is increased. Second, hyperparathyroidism with bone involvement. You know this enzyme? Parathyroid hormone. What is the role of parathyroid hormone related to calcium? It acts at three sites: intestine, kidney, and bone. It increases intestinal absorption. It increases renal reabsorption, and it transports calcium from serum to bone. No, reverse reaction is there. It transports calcium from bone to serum. That's why it increases the serum calcium level. Okay, and calcitriol. It is the third action is antagonist to the parathyroid hormone. But at kidney and intestine, same action is there. Okay, and also parathyroid hormone promotes the increase the plasma phosphorus level from bone to circulation. That's why increase the parathyroid hormone activity, serum phosphorus level is increased. Third is rickets. Demineralization is there. Or bone formation is impaired. Then osteomalacia and bone tumors. In that condition, some amount of phosphorus enter into the serum from bone. Hence, serum phosphorus activity is increased. The next is related to hepatobiliary disease. First is obstructive jaundice. There is obstruction of bile duct, and this enzyme is mostly present in bone as well as bile duct. That's why in this obstructive jaundice, high amount of serum alkaline phosphatase activity is observed. Because this enzyme is secreted from bile duct and then enter into the intestine. And in the intestine, also this enzyme is used for the digestion purpose. But here in this obstruction, this enzyme is not entered into the intestine. That's why it is entered into the circulation. Hence, activity is increased. Also, hepatitis or hepatic jaundice. Also, it is concerned with bile duct. That's why moderately increased alkaline phosphatase activity is observed. Or biliary cirrhosis. Also, it is related to root of the enzyme activity. That's why in these conditions, alkaline phosphatase activity is increased. High values are also seen during healing of fractures for the mineralization purpose. Okay. The last point, serum alkaline phosphatase activity. You have to write in this point. Then you have to write the some readings of this practical. Write only observations. For this estimation of serum alkaline phosphatase activity. First write the reading of blank 0.012. Second, standard 0.021. Third value, control 0.08. And last, unknown or test 0.14 40. By this reading, you have to calculate the serum alkaline phosphatase activity. This These are the reagents used for the estimation of serum alkaline enzyme activities. Blank is 0.12, correct? 0.12. Blank will be 0.12, standard 21, control 0.08, and unknown 0.14. Standard is standard is 0.21. 0.21. 30. Now, these are the reagents are used. First, take the 1.1 ml of the phosphate buffer substrate, sodium phenolphosphatic all use. Huh? Take one look there. It is nothing. So procedure part है. Look at this procedure to look here. Journal. What the look here? Table look here. इसके लूंगी आप अगर करूँ देना मिक्स कर पार्टीशन ऐकायला जातंय का जातंय तर ते लिमिट करायला लागेल स्टार्ट व्हिडिओ मध्ये आता दिसतोय ना आपल्याला चालू कर स्टार्ट कर in this all tubes 1.1 ml substrate is added Then add buffer in control as well as in unknown 1 ml. Here is the video start. Last controller add 1 ml. Then he is adding the buffer in control and unknown groups. Quantity is 1 ml. Then add distilled water 1 ml distilled water in black. Then add 1 ml phenol standard in standard group. Then mix and incubate 5 minutes. Okay. Will not wait. Directly add the serum. Then add serum in only unknown tube. 0.1 ml. Then incubate 15 minutes. Okay, at 37 degrees centigrade. This is the time provided to this enzyme for the hydrolysis purpose. In that time, this enzyme hydrolyzes diphenyl phosphate to phosphoric acid and phenol. In this step, amount of phenol liberated reacts with some other chemicals. For example, 4-amino antipyrine and phenol. Here we are using some alkalis, NaOH and sodium hydrogen carbonate. What is the role of these two chemicals? Provide alkaline medium for this action of this enzyme. Okay. Then after the addition of all these reagents, then you will get colors like this. Okay. Now see. You will get colors like this. This is the color of black. Then this is the color of control. Then this is the color of standard. And last is color of unknown. And this color is depends on mostly how much amount of phenol liberated by the action of alkaline phosphatase enzymes. And all of you know how to take the readings of these colors by colorimetry. First start the colorimetry, then set the filter 530 nanometers. Then take the distilled water in QA and set the 0 readings of the colorimetry. Then take the reagent blank and take the reading. Then control, then standard and then unknown. Then you will get the all readings. And the readings are provided to you. By this reading, you have to calculate the how much amount of alkaline phosphatase enzyme present in given serum. Whether it is within normal range or increased or decreased. Mostly this enzyme will not decrease. Mostly this enzyme is increased in some physiological conditions like pregnancy and growing children and other pathological. First related to bone disorders and second related to hepatocellular disorders. Okay. Any problem? Any doubts of these products? Okay. Then you have to write this estimation in your journal. You have to write all the estimations completed by our department. Also, you have to write some special techniques. For example, colorimetry, spectrophotometry, buffer preparation and pH meter, our arterial blood gas analyzer, etc. Also, you have tried normal constituents of the urine, abnormal constituents of the urine, estimation of blood glucose, urea, serum creatinine, urine creatine. In that urine creatine, you have to calculate creatinine clearance, etc. You have to complete all these practicals in your journal. Here, this part is completed. काही प्रॉब्लेम नाही आहे यामध्ये करता येईल तुम्हाला नंतर व्यवस्थित